Hello and welcome to Subnetting 3 of 4. Today's topic is the same subnet. Of course, we will have learning objectives, a why do you need it section, a few exercises, a learning verification, and a summary. Learning objectives. Now, these are the objectives of questions you will be able to answer after going through the training today. How can one determine whether or not hosts are within the same subnet? Is it possible for one host subnet to overlap another host subnet? Why should communication fail in overlapping subnets when Proxy ARP is disabled? With regards to ARP, what happens if one host subnet overlaps another host subnet and Proxy ARP is disabled? With regards to ARP, what happens if one host subnet overlaps another host subnet and Proxy ARP is enabled? Why do you need it? Well, by knowing the network address, broadcast address, and usable range, one can make informed decisions when evaluating what a host will do on the network. Namely, one will be able to determine whether or not IP addresses are within the same subnet as a host, which affects what IP addresses the host will ARP for. Recall from an earlier lesson, ARP, that if hosts are on the same network, then the end host will ARP directly to obtain the Ethernet address. If hosts are not on the same network, then the end host will need to ARP for its default gateway. Thus, subnetting is crucial for end host operation on the network. So, exercises. Number 1, what is Proxy ARP? Well, Proxy ARP is a feature whereby the router on the network can respond to ARP requests for destinations that may not even be on the same physical network. In regular ARP, it does not go beyond the local segment. Thus, Proxy ARP can be used to facilitate transparent subnets. Exercise number 2. With regards to Proxy ARP, what happens if hosts are not in the same subnet? Well, if hosts are not in the same subnet, then Proxy ARP can allow these hosts to communicate when the router takes responsibility for providing ARP resolution for hosts that are on different and sometimes overlapping networks. Exercise 3. Now you get to use some of those subnetting skills that you have developed so far. Are these hosts in the same subnet? And you see here we have a couple host IP addresses provided, host 1 and host 2, and then we have a router with several IP addresses that are configured on the router. As you should be familiar with this slash notation here, this does refer to the prefix linked, which is synonymous with your subnet mask in dotted decimal format. Okay, so now as you can see, we're looking at the answer here and we've reached our conclusion. So first you can see we discovered what was the network address, the broadcast address, the first usable address for a host, and the last usable address for a host. And we did that for all of these here. And now we can see clearly if we compare the ranges here that host 1 and host 2 are not in the same subnet. These are not in the same subnet. As you can see, the network address is different, the broadcast address is different. They're not even in the same range. This goes from 0 to 7. This goes from 8 to 15. So there's nothing here to say. Now notice this router interface is in the same subnet with host 1, and this router interface is in the same subnet as host 2. Feel free to recheck this work. This is a very important concept here, to know that these addresses, whether or not they're in the same subnet. Exercise number 4. What happens when host 1 tries to communicate to host 2 and vice versa? Proxy ARP is disabled and the router is the default gateway. In this case, each host will attempt to ARP for its default gateway and traffic will be sent to the default gateway. As stated, Proxy ARP is disabled in this example, so it has to be a non-factor. Also, the router is the default gateway. So we see here host 1 and host 2. This is the same subnetting example we did prior. As you can see, they're in different subnets. And we're assuming here that this router is the default gateway for host 1 in this subnet. And this interface on the same router is the default gateway for host 2 in this subnet. And so if host 1 tried to communicate to host 2, it would ARP for the Ethernet address of this router interface, which is configured as host 1's default gateway. Exercise 5. What happens when host 1 tries to communicate to host 2 and vice versa? Proxy ARP is enabled and the router is the default gateway. Okay, in this case, we must first determine whether or not these hosts are in the same subnet or not. So we compare and we look here and we find that host 1 and host 2 are in different subnets. And so in this case, proxy ARP will be a non-factor because proxy ARP is a non-factor specifically because these hosts are configured for a default gateway and they will ARP for their default gateway. Don't have to worry about proxy ARP in this case, even though it's enabled. Exercise 6 of 11. Are these hosts in the same subnet? Now notice in this example, we have host 1 configured with this subnet mask. We have host 2 configured with this CIDR notation, /28, whereas host 1 is configured with a /29. Let's get an answer on the next slide. Okay, so for host 1, we see what's the network, what's the broadcast, what's the first and the last. Now look at host 2. It actually has the same network and first available address as host 1. So host 2 actually is overlapping with host 1 subnet. As you can see, this goes from this 10 0 to 15. This goes from 0 to 7. So this one overlaps this one, but as you will note, from the perspective of host 1, this 10 is outside of this subnet because the broadcast ends at 7. So from the perspective of host 1, host 2 is in a different subnet. But from the perspective of host 2, host 1 is in the same subnet. Look carefully because it says, see, host 2 is in this /28, and look at this range here. And so this type of misconfiguration does appear on real networks where hosts won't have the same view of what subnet they're in. Okay, exercise 7. Now what happens when host 1 tries to communicate to host 2 and vice versa? Proxy ARP is disabled. Okay. So these are the same addresses we looked at previously, so we should be familiar with host 1 thinks it's in a different subnet from host 2, but host 2 thinks it's in the same subnet as host 1 because the range that is allowed has host 1's addresses within their range. Now, so from the perspective of host 1, host 2 is in a different subnet. Host 1 will ARP for its default gateway if it needs to send traffic to host 2. But from the perspective of host 2, host 1 is in the same subnet. Host 2 will then attempt to ARP directly for host 1. In this case, with proxy ARP being disabled and host 2 attempting to ARP directly for host 1, host 2 will not be able to get an ARP response for an Ethernet address to connect to host 1. Now, exercise number 8. What happens when host 1 tries to communicate to host 2 and vice versa? In this particular case, proxy ARP is enabled. You will note this is the same question as exercise 7, except now we turn proxy ARP on. Now let's see what would happen. Now, as stated before, from the perspective of host 1, host 2 is in a different subnet, because 1 goes from 0 to 7 and host 2's address is 10. So, and from the perspective of host 2, host 1 is in the same subnet. So now, when host 1 attempts to communicate with host 2, it says, oh, you're in a different subnet. Let me ARP for my default gateway. And then the default gateway will return this Ethernet address, and I'll send the traffic on that way. Now, from the perspective of host 2 attempting to communicate to host 1, host 2 says, host 1, you're in my same subnet. I'll just ARP directly for host 1. Unfortunately, they're not actually in the same subnet, but host 2 thinks they are because host 2 is misconfigured. Now, because Proxy ARP has been enabled on this router, it will see that request and say, oh, I know what you really are trying to do here. Let me help you out. And it will say, okay, use this Ethernet address to get to host 1. Wink, wink. I'll help you out. And that's what happens in that case. And that enables that communication. Exercise 9 of 11. Are these hosts in the same subnet? In this case, both of these hosts are in the same subnet. As you will note, this is this /28, this also /28, but that's not enough. You actually have to compare this IP address and the mask to discover what the network address is, and then also make sure you discover what your broadcast address is. And you can see from this, they're identical ranges. Now, if you'll note, this router interface does not have a subnet in common with either of these hosts. Exercise 10. What happens when host 1 tries to communicate to host 2 and vice versa? Proxy ARP is disabled. In this case, host 1 will think that host 2 is in the same subnet based on, the configured mask. So it will say, you're in the same subnet, let me ARP for you directly. Host 2 will do the same thing because it also thinks host 1 is in the same subnet. Proxy ARP is a non-factor in this case, as both hosts are actually in the same subnet. Exercise 11. What happens when host 1 tries to communicate to host 2 and vice versa? Proxy ARP is enabled. Let's pay attention to what their addresses are. Okay, this is the same exact addressing as before. Now, host 1 thinks that host 2 is in the same subnet. So host 1 ARPs directly for host 2. Host 2 thinks host 1's in the same subnet. So host 2 ARPs directly for host 1's IP address. Now, Proxy ARP is a non-factor, even though it's enabled, because the hosts are in the same subnet. There's no issue here. Learn-in verification. How can you determine whether or not hosts are within the same subnet? Is it possible for one host subnet to overlap another host subnet? Why should communication fail in overlapping subnets when Proxy ARP is disabled? With regards to ARP, what happens if one host subnet overlaps another host subnet and Proxy ARP is disabled? With regards to ARP, what happens if one host subnet overlaps another host subnet and Proxy ARP is enabled? To determine whether or not hosts are in the same subnet, determine if they have a common network address and broadcast address. It is possible for one host subnet to overlap another host subnet. As you can see in this example, this host right here says it's in the 10/8 network, which has this capacity for 16 million addresses, which actually overlaps with these. So if this host wanted to communicate to this host over here, it would actually just ARP directly for this host, and it will do the same thing trying to get to this one. Unfortunately for this host, unless Proxy ARP is enabled right here, it will not be able to communicate over here. It will not be able to communicate over here if Proxy ARP is not enabled. Now, next summary. If Proxy ARP is disabled, communication will fail in overlapping subnets because each host has a different picture of the network. One host will think it's in the same subnet, so we'll ARP for the destination host directly. The other host will think that it's in a different network, and then it ARPs for its default gateway. Regardless, there cannot be bidirectional communication since only one host will be right about where the other host is. Well, from their perspective, each host thinks it's right, but in reality, you know how that goes. Now, if one host subnet overlaps another host subnet and Proxy ARP is disabled, then communication should fail. So, for example, this host here is in this /8 network and it wants to communicate over here with this host, and it will say, oh, I need to communicate to 10.0.0.10. Let me ARP for you directly, and it will not be able to actually communicate with this host because Proxy ARP is not enabled. So the router will not say, oh, here's the Ethernet address for that host. I took care of that for you. So you really have to be careful that your subnets don't overlap in this manner in your network, unless you want unexpected results. Finally, if one host subnet overlaps another host subnet and the Proxy ARP is enabled, then communication will succeed, similar to the transparent subnets example. Now, with the transparent subnets, you actually had cases where the hosts themselves were not actually aware that they were on different cables, and the network infrastructure handled the subnetting for them to enable those hosts to communicate. But in this case, this host will say, oh, I need to talk to something over here. I don't realize it's in a separate subnet because of how I'm configured here. And if you want to check, you can actually check this and see what the range is for network and broadcast for 10.12.0.12/8, and you will see, wow, the network is 10.0.0.0 and the broadcast is 10.255.255.255. So this is well within that range. So I'll just ARP for it directly, and I'll ARP broadcast out, hey, anyone know where I can find it? And with Proxy ARP enabled, the router says, sure, you can find it over here. Because I have Proxy ARP enabled, I will help you out. Just send it to me, I'll take care of it for you. And that concludes today's lesson. I hope you had very much fun on subnetting 3 or 4 the same subnet.